So this is our proportional relationship foldable. And we're actually going to, and just fold it all the way across, but we're actually going to start by looking at this definition here. So the first thing we need to remember about this is this relationship between two variables. And those variables are y and x, so you'll see those in tables and graphs, where their ratios are equivalent. And remember, equivalent just means equal or the same. So go ahead and get that down. And then when we think about proportional relationships and ratios, we know we're comparing two things. So the three ways we write ratios. We write y colon x, y to x, or the one we're going to use, y over x. And we're going to be using this one a lot, so make sure you get it down. Okay? So that's just our definition. In short, it just means we're comparing y and x, those ratios that we create, and we're going to see if they're equal throughout the entire graph, throughout the entire table, throughout the equation. Okay, so let's close it. Let's start with our tables. We're actually going to draw a table first. So we're going to draw this table. X and Y here. Just going to break it up. And we're going to have 1, 2, 3. And then we're going to have 3, 6, 9. And we're going to leave this blank for now. And you'll see why. So a table is proportional when the x values and the y values increase or decrease by a constant rate of change. And when we think about increase, the operation that we always use is going to be add. So if it's going up, we're adding. If it's going down, we're subtracting. Okay? And so then this word constant is just going to mean it's always the same. Okay? So let's now look at our table and see if we have a constant rate happening. So let's look from 1 to 2. That's plus 1. From 2 to 3, we're adding 1 each time. So that is constant. From 3 to 6, we're adding 3. From 6 to 9, we're adding 3. So this is a constant relationship that is increasing and decreasing. But we also need to make sure we have the following. So we want to go backwards. So the opposite of plus 1 is minus 1. Opposite of plus 3 is minus 3. And so 1 minus 1 is 0. 3 minus 3 is 0. So your table also has to have 0, 0 included. So that wasn't on this piece, so we're just going to add at the top. Or we'll put it here. Table has to include the point 0, 0. So please make sure you get that down. It's so important. So again, if it's increasing by the same number and decreasing by the increasing by the same number, your x and in your y, it is constant. It's proportional. Okay. So remember the words we're looking for that we want to use: proportional, increase, decrease, constant. Okay, a constant rate. So those are like the important words we're using. So now let's look at our graphs. I'm going to just draw us a graph, just like this. This is x and this is y. So when you have a graph is proportional when the graph makes a straight line through the origin, which we know the origin is 0, 0. So in our diagram, you will see that this is our origin where x and y meet. So it has to start here. It has to start at 0, 0. And then it's going to create this straight line just like this. And it's also what we call a diagonal. Okay. And then lastly, we have our equations. So when we think about our equations, an equation is proportional when it is in the form of y equals kx. And so all this means is where k is the constant of proportionality, so that constant rate of change. And some examples are y equals 3x, y equals negative 2x, and y equals 6x. And you'll see each time that k is just going to be the number attached to x. So it's 3, negative 2, and 6. Okay? And the important words we needed here were straight, origin, of course, proportional, again, constant. Okay. So again, these are our important words we want to make sure we are remembering and getting down. So now we're going to open it up. We're going to work on the inside. So the first one says, the table is proportional because, so let's go ahead and check it out. We're going to check the constant rate of change. So we're just drawing our arrows first, and we're seeing how is it changing from each one. How is it changing? So we see that 1 becomes 2 because we added 1, 2 becomes 3 because we added 1, 3 becomes 4 because we added 1, and 4 becomes 5 because we added 1. And then here, 2 becomes 4 because we added 2, 4 becomes 6 because we added 2, and you can keep seeing that we're adding 2 each time. So far, the x values increased by 1 each time. Our y values increased by 2 each time. So right now we do have a constant rate, but we have to check to make sure it starts at 0, 0, which means 0, 0 has to be in it. So we're just going to work backwards. The opposite of plus 1 is minus 1. Opposite of plus 2 is minus 2. So 1 minus 1 is 0. 2 minus 2 is 0. So therefore, also 0, 0 is in the table. Okay? So that is how we know it is proportional. 0, 0 is in the table, and it increases by 1 each time, increases by 2 each time. It is very much so constant. So now we're looking at this graph. So we know it has to start at the origin, which it does here. So starts at 0, 0. And then we know it has to be straight, which this is. So it doesn't loop, it doesn't zigzag. So therefore the graph is proportional because it forms a straight line. And it starts at the origin, which is 0, 0. Okay? And then lastly we have y equals 4x. We know it has to be in the form of y equals kx. And so we know that this is proportional because it's in the form of y equals kx. And it starts at, which means it starts at the origin. Okay? So again, we don't have any pluses or minus hanging there. It's just a number attached to x, and that's what we want. So if we move it over here, this is not in the form of y equals kx because this plus 3. This plus 3 means that it starts, the line is starting at 0, 3, and that is not 0, 0. So this equation is in the form of y equals mx plus b. You'll learn that next year. And it does not start at the origin. So this particular one starts at 0, 3. Okay? So if we were focusing on, let's say there was, we got to remember there was y equals 4x. That's the same as y equals 4x plus 0, because you're not adding or taking away anything when you just have a plus here there. So don't be confused by that, because that is simply just saying, hey, it starts at 0, 0. But again, usually you won't see that. So now we're going to focus on how do we find equations from our table and graph. So to find an equation of a table, we know it has to be in the form of y equals kx. And you need to know that k just equals y over x. And we talked about that with our ratio. So how did our y's change? Our y's, remember this is x and this is y. Our y changed by 2 each time. and our x changed by 1. So 2 divided by 1 is just 2. So now it's our job to make sure that we rewrite this equation replacing k with 2. So this is going to be y equals 2x, and that is your equation. So for a graph, we first have to make a table of points. So that's the first thing we're going to do. We're going to make a table. So if I have x and I have y, the points I have 0, 0, and I have over 1 up 10. And we can actually stop there and show that change. So if we show this change, 0 becomes 1 by adding 1. 0 becomes 10 by adding 10. So remember, you have to find k. K is going to equal y over x. So our y increases by 10. Our x increases by 1. 10 divided by 1 is 10. So we found our k. Now we just plug it in to our equation. So remember, our equation is y equals kx. So now it's just y equals 10x. Okay? So you need to know all this. Make sure you get all of this down.
Good afternoon, Franklin.
So make sure you get all of this down. Go back and go over anything you need. And you're just going to take this and you're going to glue it into your notebook. It's going to be on page 10. You'll be able to see the final product there. All right, that's it.